Assalamualaikum and good evening to the panels, Dr. Shamia Hayal and Dr. Samri, and everyone watching this video. Today I'm going to present my final year project 2 entitled Lepornia articulata as a Sustainable Acoustic Absorber. Acoustic absorber is the simplest method to reduce the disturbance into acceptable level to human ears by means of using absorptive material to absorb noise from surrounding as much as possible. The installation of acoustic absorbers weakens the sound reflection at the room and reduce the acoustic energy. What is Lepornia articulata? Lepornia articulata is the scientific name of a wild grass known as kecut, kumbuh, purun, or purun danau that was found abundant in a swamp and a long stream in West Malaysia. It is commonly used for greywater treatment, numbers traditional craft, and now commercialized as an organic straw. However, there is a scarcity of knowledge on the physical and acoustical properties of this natural fiber. Therefore, the objective of this study is to fabricate sustainable acoustic absorber based on Lepornia articulata with different arrangement, to investigate the performance of sound absorption, and lastly to evaluate the significant relationship between physical and acoustical properties of Lepornia articulata. There is not much research conducted to investigate the relationship between acoustic absorption and configuration of hollow structure. In 2006, a study on utilizing hollow structure as acoustic absorber, where the reeds were arranged in three configurations of parallel, perpendicular, and cross as shown, conclude that parallel configuration appeared to be the most effective configuration. A deeper analysis was performed by Astrobali in 2005, where in this study, the reeds was fabricated into different thickness with three different configurations as well. Results showed that the peak of ACC shifted towards lower frequency with increasing thickness in the vertical tested samples. He also concluded that the higher the thickness, the better the absorption performance. Lastly, Hire in 2006 conducted a study on the sound absorption performance on hollow tube structure made up of lollipop stick. The result demonstrated that samples with perpendicular and cross configuration showed greater absorption performance. In addition, incorporating air gap in the parallel tested samples moved the peak to a lower frequency. However, there was no effect was found by introducing the air gap in the perpendicular and cross tested samples. As we can see here, the flow chart shows the process of this research. In this study, there are 4 different arrangements of samples, namely axial, horizontal, cross, and combination were assessed. The diameter used for each arrangement ranging from 2 to 4 mm and 4 to 7 mm respectively. This means there are 2 different range of diameter of Lepornia articulata for each arrangement. In the axial configuration, 3 different lengths were cut, bonded together and arranged in overlapping manners. It can see in the figure 2.4, where increasing the amount of layer will make the path more intricate. For the horizontal and cross configuration, we are using the same method as previous study. Lastly, in the combination configuration, there are 2 types of combination configuration used. Where the first combination is combination between horizontal and axial configuration, where several layers stack in the horizontal direction in both ends until the thickness is 50 mm. This procedure is similar in preparing for the combination of cross and axial configuration, but each layer was positioned perpendicularly to one another in both ends until it received the constant thickness of 50 mm. In the combination configuration, the axial stack of 25 mm was placed in the center before the horizontal and cross was arranged in both ends. Next, the acoustical properties were measured using impedance tube method based on standard international of ASTM E105098 as shown. Then a gap of 0 to 25 mm in 5 mm of increment is introduced in each sample. The NRC is calculated using the equation by taking the average value of the sound absorption at 4 different frequencies. Moving on, there are 4 different topics that we are going to discuss in the results and discussion, which is the physical characteristics, sun absorption coefficient, influence of air gap, and also noise reduction coefficient. The table shows the physical characteristics of these samples. Since we are using 2 different Stokes diameters, samples P is with a bigger Stokes diameter of range 4 to 7 mm, and sample C is with a smaller Stokes diameter with range of 2 to 4 mm. Arrangement 1, 2, 3 is a fiber in axial configuration, where arrangement 1 means it is with a layer of axial configuration, arrangement 2 means it is with a 2 layer of axial configuration, and arrangement 3 is fiber arranged in 3 layer of axial configuration. 4 and 5 indicate horizontal and cross configuration respectively. Lastly, arrangement 6 is the combination of horizontal and axial configuration, and arrangement 7 is the combination of cross and axial configuration. If we compare between samples B and C with the same arrangement, the samples made up of a bigger Stokes diameter demonstrate higher density than the samples made up of a smaller Stokes. The porosity of samples made up of a smaller Stokes diameter arranged in axial configuration showed a significantly higher porosity than the samples made up of a bigger Stokes diameter. When density increases, the porosity decreases. The amount of labrana articulata and its diameter size will indirectly influence the porosity and other physical characteristics of the acoustic absorber. Lastly, the tortuosity is inversely proportional with the porosity. The samples with horizontal and cross arrangement share the same value of dry weight, density, porosity, and tortuosity due to the same layer of Stokes are used to fabricate the samples. This goes the same for combination arrangement. In figure 4a, we can see clearly that samples, when it is fabricated with a smaller diameter range, demonstrate a good acoustic absorption compared to samples with bigger diameter range. Unfortunately, samples C2 and C3 suffered a severe declination from SAC value of 0.8 to 0 absorption. This is probably because the samples are too packed, which deteriorates the acoustic absorption performance at certain point. The absorption performance of material is higher for a denser materials due to an increased frictional surface between the acoustic wave and also the fibers. At a certain limit, frictional effect between the acoustic wave and fibers less, since it is difficult for the acoustic wave to penetrate in material with fewer pores. Next, we can see in figure 4b, if we compare between cross and horizontal arrangement, cross arrangement demonstrated higher SAC values compared to sample with horizontal arrangement throughout the frequency. Lastly, for the combination arrangement, it is best to conclude that samples made up of a smaller Stokes give an optimum sound absorption property, especially at higher frequency range compared to samples made up of a bigger Stokes diameter. What is the influence of air gap in samples made up of bigger Stokes diameter? As we can see in figure 5a, it shows that the absorption performance decreases as the air gap increases when the sample is arranged with the axial arrangement. This goes the same to a double layer of sample arranged in axial direction. Next, we can see in figure 5c, it shows that by comparing all the plots, the SAC increased but reached its maximum at 15 mm of air gap in samples with a triple layer of axial arrangement, and further increasing the air gap will result in declination of SAC. Next, we can see for figure 5D, E, and F, the range of difference value of the peaks between with and without air gaps for all the samples of these samples are within the range of 0.05. This low range indicates that the absorption performance for horizontal, cross, and combination of horizontal axial arrangement does not affect by the thickness of the air gap. Last but not least, we can see in figure 5G that by further increasing the air gap does not significantly demonstrate any much difference in the SAC value of the combination of the cross and axial arrangement. For samples made up of a smaller flux diameter, it can be seen clearly that there is no dramatic declination in figure 6a and 6b when the 5 mm of air gap is introduced to the sample. The SSE value decreased as the thickness of the air gap increased in sample C1 and C2 due to the range of difference between the SSE values are more than 0.05. Next, we can see in figure 6C. Here we can see that the highest peak are also reduced and shifting towards low frequency with an increasing of air gap. Last but not least, the sample of C4, C5, C6 and C7 only influence the SSE value at a low frequency range, whereby the highest peak of SSE is shifting towards more lower frequency range. Besides, it creates a new peak within the frequency of 1000 Hz to 2000 Hz as the thickness of the air gap increase. If compared with and without air gap, the value of the SSE with air gap is lower at the same frequency. The range difference of the highest peak between with and without air gap in these samples showed that it is less than 0.05. This low range indicates that the air gap does not influence the SSE value of samples C4, C5, C6 and C7, although a new peak is introduced. Here we can see a figure showing the NRC of the samples. The NRC value must be rounded off to the nearest multiple of 0.05 and ranging only from 0 to 1. Higher value of NRC indicates that the sample has better acoustic performance. If we compare between samples with diameter ranging 2 to 4 and 4 to 7 mm, there's a huge difference found for the axial arrangement, whereby the NRC value of sample C is higher compared to the sample B. Overall, the NRC of all samples are greater than or equal to 0.02. Hence, we can say that Leporello articulata has the potential to become acoustic absorber. This is because Rosings once stated that the NRC values that is less than 0.2 are considered to be reflective, while NRC value greater than 0.4 are considered to be absorptive material. In conclusion, the result revealed that the horizontal, cross and combination arrangement showed the greatest absorption performance compared to the axial arrangement. We can see that bigger stocks diameter in axial arrangement exhibit the least NRC value. This is because when you use bigger stocks diameter, there's less fibers in the samples. In addition, air gap has great influence at low frequency range. In terms of incorporating air gap, further increasing the air gap will reduce the absorption performance once the sample has achieved its maximum absorption at certain thickness. Besides, we can see that the sound absorption coefficient increases as the porosity increases and decreases as the density and tortuosity increase. Overall, Leporello articulata has the potential to be used as a sustainable acoustic absorber, as all the sample has the NRC value more than or equal to 0.2. Due to the pandemic and some restriction, there were some changes in this research. Initially, alkaline treatment with 4% of sodium hydroxide solution for 4 hours was done, but then the fibers were degraded, shrink and twisted. Therefore, the researcher recommend that the effect of soaking time and concentration of NaOH solution should be investigated to determine the optimum fibers treatment parameters and improve the absorption performance. Next, further investigation on the dimension of the structure using scanning electron microscope, flow resistivity, water content and alkaline treatment should also be done. Last but not least, it is necessary to extend this research using laboratory apparatus in controlled environment to determine the physical characteristics to reduce uncertainties and error, because in this research we are using home apparatus to determine the density and porosity of the Leporello articulata. That's all from me. Thank you and have a good day.